Greetings everyone. Today we're going to explore the basics of planes and functions. You should have a foldable for this to make things a little bit easier. All right, let's start off with the basics, and my hope is that this is a review for you. We're going to label this coordinate plane with all of the needed information. Let's start off with the x-axis. The x-axis always runs horizontally, and the y-axis always runs vertically. The origin always occurs in the center of our axes. For the quadrant numbers, you always want to start with quadrant 1 with the first quadrant you ever learned, which was the top right. We then go counterclockwise to identify our quadrant numbers. Now you'll notice I used Roman numerals. I'm okay if you just use digits. An ordered pair is just making sure you understand that an ordered pair is x comma y. Therefore, the x coordinate is always first, and the y coordinate is always second. Now those coordinates can occur anywhere on your coordinate plane. Quick review of plotting points. 4, 3 means right 4, up 3. So we're just remembering here that if you are positive, it's right and up. Negative 2, 1 would be left 2, up 1. 5, negative 2 would be right and down, so right 5, down 2. Negative 6, negative 1 would mean left and down, so just making sure you remember what do we do for negatives versus positives. Let's take a look. 0, negative 7. Watch out for this. This means 0 left or right, down 7. So this is going to occur on the y-axis. 3, 0 means right 3, and that's it. Okay, so watch out for that. Oops, I should have been labeling my letters. It's okay if you don't have that. Let's take a look. Negative 3, 3. So just be careful when the numbers are the same, but the signs are different. So that's going to mean left and up. Very often mixed around, so just take time to read that clearly. And our last one, 5, negative 5. Right 5, down 5. So it's always left or right first, and then up or down. If you need help with graphing coordinates, make sure you let me know. All right, let's go into a definition here, which should be on your foldable. We're going to talk about the word analyze. To analyze means to examine carefully in detail, and we know this just from English class, science class. You might analyze a text, you might analyze, let's say in an experiment or a lab, but we want to identify the nature and relationship of the parts. Those parts depend on what topic you're dealing with. So for example, we're going to analyze this table. So the first thing I notice is the topic is to do with sunscreen. As the number of uses increases, the amount of sunscreen decreases. That makes sense. And if I look, we actually have a consistent decrease of subtracting 0.2 ounces every use. So let's talk about some of these questions. The amount of sunscreen in the container blank after each use. I'm open to which words you use, but the key thing I need to see is, do you know that it decreases, goes down? If you're even more specific, decreases by 0.2, that'd be fantastic. The amount of sunscreen in the container changes, and I'm going to say negatively. Okay, when we're talking about subtracting a value, that would mean it's decreasing negatively. The graph, if I was to graph this, should blank at a slow rate, meaning if I did a quick little sketch, I'm here, and then I'm here, and here, and here. So if I connected my dots, that graph should decline at a slow rate. All right, because it's very little. It's only 0.2 of a change. All right, let's take a look at analyzing this graph. We're talking about cell phone cost, which you're going to have to think back to when I was younger and had a cell phone. Let's relate it to, instead of minutes of calls, let's think about data. All right, that's a little more comparative to what you're used to. So you have this base cost, right? Let's say you get 4 gigs of data. No matter what, you pay a certain amount. But if you go over that data, then your cost increases at a certain rate. So the cost of the cell phone in June blank with the number of minutes of calls. So in general, we would say it increases with the number of minutes of calls. We're going to say with the number of gigabytes or data used. The cost of a cell phone in June is blank for the first part of the month. So the cost, if you notice, it goes straight, it's left to right, it's horizontal. So we would say the cost of the cell phone in June is constant for the first part of the month. So you're going to hear that word constant a lot more on our graphs. Describe how the variables in the graph are related. So we would say as the data usage increases, so does the cost. So notice I'm addressing each axis, name, data, and cost. Those both need to be in your sentence. And we're describing the general change, which is increasing. All right, sometimes we're going to be asked to create a graph from a story. So in this case, we're thinking about sitting on a swing. And we're moving back and forth, swinging higher in the air. So we're talking about a height. And then it says slowly you swing to a stop. So we're talking about over time. If time is an element, it will always be your x-axis. Okay? If there's any element of time, it's x-axis every time. So just assume that for this class. And then we're talking about how high I am in the swing. So the y-axis is going to be very literal, and it's going to be our height. So if I sit on a swing, I'm a little bit above the ground, right? If we're considering height as a relationship to the ground. Now, as I push myself backwards, my height increases a little bit. And then as I come forward, my height is back just a little bit above the ground, and then I'm going forward a little bit higher. But each time I approach the ground height again, and I go backwards and forwards, but then I slowly want to decrease. If it was abrupt, my graph would end quickly, but it's like I'm just hanging out and I'm slowly going to stop. So with our graphs, let's stick to lines and segments on our graphs. We want to definitely label the x and y axis appropriately. So always label, that's very important. And then look for keywords like slowly, back and forth. Think about those keywords that help me determine what my graph should look like. All right, this time we're going to match the descriptions with the graph. We're talking about, it looks like water coming out of a cup. So first it spills, then I'm pouring water into it quickly, then I stop pouring water, then water leaks from a hole, and then I'm pouring water out of the cup slowly. So really we're talking about, again, an element of time. And this would be the amount of water in my cup. So I'm starting with 0 water in my cup, and then it increases quickly. So if it's increasing quickly, I'm probably pouring water in quickly. So that would be my A. Now there's still water increasing, it's just at a slower rate. So I'm pouring water into the cup slowly because I don't want it to overfill. This next segment is steady, meaning the height or the amount of water is not changing. So I've stopped pouring water. Then notice this quick decrease. It changed very quickly. I lost a lot of water in my cup, which means I probably spilt it. and then slowly decreasing over time. It's a slower rate, so therefore the water is leaking from that hole in the cup. So key things we're looking for here are words. So slowly. Interpreting that pouring water means into a cup means increasing. Know that leaking means decreasing. Stopping means steady. Into quickly, a quick increase. Spilling would be a quick decrease. So interpreting the vocabulary in a positive and negative line. All right, let's take a look, switch gears a little bit and talk about another definition called function. A function is a relationship that pairs each input with exactly one output. Each input with exactly one output. So that's going to be very important there where I underlined. We're going to decide if relationships are functions using a few different methods. We're going to look at some mapping images. We're going to look at some tables of numbers. And we're going to look at some graphs. Now, to think about input another way, we can also relate it to our x values or our domain. So each x value has exactly one y value. See how I can change the words input and output? So we're going to relate those and hope and look for that each x has exactly one y. So let's put this into practice to make more sense. If I look at this first one, I'm trying to decide, is it a function? Does each x have its own y value? And if I look, yeah, there's only 1, 1, 1, 3, 1, -2, and 1, -5. There's no x's repeating. So is it a function? Yes. I'm going to say no repeating inputs. Now, if you wanted to say x's, I'm okay with that, but because my title says inputs, that would be more appropriate. Let's take a look here. I have 1, but I've used it twice. I have 4, but I've used it twice. That's not good. So is this a function? No. Because there are repeating inputs, that's bad. All right. So I'm going to say because repeating inputs. All right, let's take a look at this one. I've used -1 once, -2 once, 1 once, 2 once. So is it a function? Yes. Okay, because there's no repeating inputs. That's good. I don't want repeating inputs. Now be careful. Some students get confused. They say, wait, the output was used multiple times. That doesn't matter when we're determining if it's a function. Okay, I'm concentrating on the inputs or the x values or the domain. Let's look at this one. Take a moment. What do you think about that domain? Ooh, look right here. See how that 1 breaks off to 2 ranges? So is this a function? No, because there's a repeating domain value. So you will be asked to explain. So make sure you have those explanations written down in your notes so you can reference them. Let's take a look at this one. Look at my domain values. They're all unique, right? I didn't reuse any of them. So is this a function? Yes, that's good. You could use that word unique as well. You could say all unique domain values. You could say no repeating domain values. Now notice that range. See how we only used one range value? But that doesn't matter. That's okay. All right, now let's switch gears. Now we're looking at a set of points. Now remember, I care about the x values, the inputs, the domain. If I look at my x values, what do you notice? Uh-oh. There's 2 ones, so is this a function? No, because repeating x values. Notice how I label them based on what information I'm given. These are x's, x coordinates. So I'm being specific on what's repeating. Let's take a look here. I have a 2, a 3, a -1, a 4. Notice how I'm ignoring the y values. I don't need the y values to determine if it's a function. All of these are unique. They're all different. So is this a function? Yes. Because there's, and I'm going to show you a few ways to write this, because, whoops, sorry about that. No repeating x's. That's a good thing. Some people don't like the whole yes, no. So you could see yes because all unique x's. If you like to keep a positive statement positive, that would be another way to write it. Now for a graph, we actually have an easier way. We're still looking for unique x values. We're still looking for no repeating domains. But we have sort of a visual way that makes our life so much easier. And that's called the vertical line test. So next to that, let's put an abbreviation, VLT, vertical line test. You can use the abbreviation only if you remember what it stands for. So the vertical line test crosses only one point on the graph if it's a function. So if I draw a vertical line, there's only one intersection point. That's good. Is it a function? Yes. If I draw a vertical line through my graph and it crosses more than once, that's a no, not a function. Now you can draw those lines to show proof. You could hold your pencil on there to show proof. So let's apply this. If I draw a vertical line, crosses once, vertical line, crosses once, vertical line, crosses once, that's good. Is this a function? Yes, because it passes the vertical line test. Let's take a look at this graph. If I draw a vertical line, whoa, look what happens. 1, 2, 3. I don't need to draw any more. Is this a function? No. It fails the vertical line test. You only want it to pass through once. You could also look at it from repeating x values. This would be maybe a 1, 0. This would be maybe a 1, 8. I'm just making an estimate. And this would be like 1, -8. So you can see I'd have the same x value multiple times. Let's look at this one. I'm going to check a few times here. Once, 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 once. So no matter where I go, it only passes once. So that's good. Is it a function? Yes. It passes the vertical line test. You have to make sure the vertical line test passes everywhere. So that's why I drew a few of those. Oop. Nope. Big no. Look at that. 2 of the same. It crossed at 2 points, same x values. So is this a function? No. It failed the vertical line test. If you wanted to put no repeating inputs or no repeating x values, I'm okay with that if that's easier for you to remember. So we kind of covered a lot of basics on this video. So key things, we're talking about the coordinate plane. Can you label all the pieces? Can you graph points okay? Then we took a look at, is it a function? So that depends on repeating x's, repeating domains, or the vertical line test. So again, if you need to just re-listen to any of these topics, make sure you go back and without writing, re-listen. As always, make sure you check out Google Classroom, see if there's anything that you need to work on, if there's any more tasks to complete. And until next time, have a good one.